Hi, and welcome to my TED Talk Show. My name is Desmond Manan, and I will become your host for today. So recently, students from Chemical Engineering section, or also known as ICOL students, were given a task about enzyme immobilization, and they have to do some research about it. So I have absolutely no idea what enzyme immobilization is. So I invite two genius students to this talk show to talk about it. Please welcome Farah, Nabila, and Adila. Welcome to the show.
Thank you for having both of us.
Thank you for coming. Can you please introduce your name?
My name is Adila binti Ahmad Fuad, and now I'm currently in the second year.
Hi, my name is Nabila, and I'm also in my second year, and apparently we're both classmates.
So you're here to talk about enzyme immobilization. Is this your assignment?
Yes, this is actually our second assignment.
It is under the subject of Introduction to Biochemical Engineering, and
Our lecturer name is Madam Rusma Warnas.
Oh, I see. Can you define what is enzyme immobilization?
So before we proceed to enzyme immobilization, let me explain a little about what is enzyme. So enzyme are complex biological molecules, primarily or entirely protein, which behave as a biological catalyst. It produced by living cells such as animal, plant, and microorganisms. It helps increase the rate of reaction in the body by lowering the energy activation, but do not get used up in the process. So almost all biochemical reactions in living things need enzyme. With an enzyme, chemical reaction go much faster than they would without the enzyme. So enzymes are normally very specific in their action, often targeting only one specific reacting species which known as substrates. So, what is enzyme immobilization? Enzyme immobilization is the process whereby the movement of enzyme, cells, and organelle in space is completely severely restricted, usually resulting in a water-soluble form of the enzyme. So, in the easy way, enzyme immobilization is immobilized enzyme that are attached to insoluble support medium, which is known as a carrier.
So why there is enzyme immobilization?
In the most of the process, enzyme mixed in the solution with the substrate, and it cannot be economically recovered after the reaction, and the enzyme are generally wasted. Therefore, there is an incentive way to use enzyme in immobilized or insolubilized form so that they may be retained in a biochemical reactor for further catalysis. So there are 5 methods of immobilization in use. So the first one is adsorption, second one is covalent bonding, the third one is entrapment, the fourth one and cross-linking, and the last one is encapsulation behind a selectivity permeable.
Okay, so you talk about adsorption method. Can you briefly explain to the audience what is it about?
Adsorption method is one of the oldest and the simplest method of enzyme immobilization. Nelson and Griffin used charcoal to absorb invertase for the first time in 1960.
So, fun fact, invertase is an enzyme that catalyzes the hydrolysis of sucrose into fructose and glucose.
So, in this method, enzyme is absorbed to external surface of the support, where the support or the carrier use mainly one of the different types such as mineral support and organic support. So, there is no permanent bond formation between carrier and the enzyme in the adsorption method. Only weak bonds stabilize in the enzyme to support the carrier. So the weak bond involved are mainly ionic interaction, hydrogen bonds and van der Waals forces. So the greatest advantages of adsorption method is that there will be no pore diffusion limitation since enzymes are immobilized externally on the support or the carrier.
What is covalent bonding?
So the second method is the covalent bonding. It is one of the widely used methods of enzyme immobilization. This method involves the formation between the chemical groups in enzyme and to the chemical group of the support or carrier. Hydroxy groups and amino groups of support or enzyme form covalent bond more easily. So the chemical groups in the support or carrier that can form from covalent bond with support are amino groups, hydroxyl group, carboxyl group and phenol ring. So there are many advantages of this covalent bond method. The first advantage is its strong linkage of enzyme to the support. The second one is no leakage or desorption of the problems, and the last one is the comparatively simple method.
So although covalent bonding have several advantages, it also have a disadvantages, which is the active site can be inactive because of the bonding. So how to overcome this? You have to immobilize the enzyme in the presence of enzyme substrates or competitive inhibitor.
Okay, so the third method is entrapment. Can you describe more about it?
Okay, entrapment method is enzyme are physically entrapped inside a porous matrix. Bond involved in stabilizing the enzyme to the matrix may be covalent or non-covalent. The matrix will be water-soluble polymer where the form and nature of matrix varies with different enzyme. Pore size of matrix is adjusted to prevent the loss of enzyme, and it can be adjusted with the concentration of the polymer used. So the examples of commonly used matrices for entrapment are polyacrylamide gels, agar and gelatin. So the advantages of this entrapment method is it is a fast method immobilization, it uses a mild condition, and it is cheap because low cost matrix are available. So the greatest disadvantages of this method is that there is a possibility of leakage of the low molecular weight enzyme from the matrix.
The other two methods of enzyme immobilization is cross-linking and encapsulation. So for cross-linking method, this method is also known as copolymerization. And in this method, the immobilization enzymes are directly linked with a covalent bond between the various groups of enzyme through polyfunctional regions. So unlike other methods, this method doesn't use water-soluble support involved in this method. So the greatest disadvantage of this method is the polyfunctional region used for cross-linking the enzyme may be nature or structurally reform, modify the enzyme leading to the loss of catalytic properties. So for encapsulation, based on the name itself, the enzyme is encapsulated in a permeable membrane like nitrocellulose or nylon capsule. So the advantages of this method is that it is cheap and simple, and the large quantity of enzyme can be immobilized by this method. The advantages of this method of encapsulation is the pore size limitation because it has a specific shape itself, and only small substrate molecule is able to cross the membrane.
Okay, so let us recap about the 5 methods used in immobilization. So the first one is adsorption, followed with cross-linking, and then the third one is, I believe, is entrapment.
So the fourth one is the covalent bond,
And the
next
fifth
one
is the encapsulation.
Is there any immobilization technology that are being used in the industry?
Well, certainly there are many uses of immobilization technology. used in industry nowadays. Firstly, in bioprocess technology, where historically the most important area of immobilization is mainly brewing, anti-brewing alcohol, antibiotics, cell structure, and extensive development in progress with new products, namely polysaccharide, drugs, and also solvent, protein-enriched foods. Secondly, it is used in the enzyme technology, which is used for the catalyst of extremely specific chemical reactions to create specific molecular converters, which are the using bioreactors. So the products formed includes amino acid, high fructose syrup, semi-synthetic penicillin starch. The third is the waste technology, which has importance, but the emphasis now is being made to couple with processes like conservation and recycling of resources, such as food, fertilizers, biological fuels. And the fourth is the environmental technology, which is the applications used in solving many environmental problems like pollution control, removing toxic waste, recovery of metal from mining waste. The next used in industry is the renewable resources technology, which uses the renewable energy sources like no cellulose to generate new sources of chemical raw materials, and energy like ethanol, methane, and hydrogen. The utilization of the plant and animal material, which is the renewable resources. Next is the plant and animal agricultural, which uses to improve the nutrition, keeping the quality, improve the yield and stress tolerance, that will become increasingly commercial available.
Okay, so earlier we talked about the immobilization technique used in the industry. So as a student, what do you think about the future of this technology?
I think researchers can research on the use of carrier-free enzyme immobilization, because this carrier-free immobilization, the advantage of this is that it can eliminate the extra catalytic mass of the carrier. This technique doesn't use any matrix to enclose the enzyme.
Okay, so is there any drawbacks of using this kind of technology?
Well, of course, it has a drawbacks, because this technique doesn't use any carrier to enclose the enzyme. So it's like a tea bag without the tea. It can be the process have to have a treatment process after that, and the carrier usually the carrier modifies the enzyme characteristic, which can be stronger, which makes the enzyme stronger. Next is that researchers can research for a broader aspects of selectivity. As we know, the enzyme has a specific conditions for it to work, like optimal temperature, optimal pH. So for this, researchers or developers can search for ways for this enzyme to work in any types of conditions, any types of pH, any types of temperature, in higher temperature, higher magnitude or greater force of pressure and temperature.
So the next future is immobilization using the nanotechnology. The future of immobilized enzyme is nanostructure, which include nanofiber, carbon nanotubes, and other nanoparticles. Enzymes such as trypsin are immobilized on the nanostructure using simple absorption and covalent attachment. This provides a larger surface area, resulting in improved enzyme loading, which in turn increase the enzymatic activity per unit mass or volume. The next one is immobilized lipids for the production of biodiesel. Before this, we used the chemical catalyst but the chemical catalyst use high energy consumption. So we substitute the catalyst by enzyme lipase. So enzyme lipase is immobilized and used for the production of biodiesel as it provides excellent catalytic activity and stability in non-aqueous media, which facilitate the esterification and trans-esterification process during the biodiesel production. And lastly, the last future technology is studies using the molecular simulation have illustrated that utility computational modeling in optimization of immobilization technique to reduce the lab material cost and create insight into molecular phenomena for the development of optimal immobilized biocatalysts. So that's all the future.
So for the last simulation step technique, instead of going to do experimental in laboratory, it is very cost efficient because it doesn't use any substrate or enzyme. It just uses the simulation or software to know the process.
Wow, it is such an amazing talk. It is very informative, isn't it? So thank you for being here talking about enzyme immobilization.
Thank you for having us. It's a pleasure to be here.
Ladies and gentlemen, give it up for Farah Nabila and Adila.
Já viu rico namorar pobre?